look at trig identities. So we have this identity here, tan squared x plus secant squared y is equal to secant squared x plus tan squared y. So at first glance, they might actually look like they're identical, but the secant y on the left is secant x on the right. Secant y on the right is secant x on the left. So we're going to work through this. We're going to prove that the left side is equal to the right side of the equation. And I'm going to work with specifically just the right side to start. Okay, so put our equal sign here for right side. And the first thing I'm going to do is use the reciprocal identity of secant squared. And the reciprocal identity is 1 over cos squared x. Technically, the 1 is squared, but 1 squared is just equal to 1, so I'm just going to leave it as the number 1. And then I'm going to use the quotient identity for tan squared y, which is sine squared y over cos squared y. Okay. Now I have two fractions, and there's an addition sign, so I'm actually going to try to add them together. But in order to do that, I need the coefficients to be, or sorry, not the coefficients, the denominators to be big. So since they need to be the same, I'm going to take this first fraction and multiply the denominator in the other. So I'm going to multiply both the top and the bottom by cos squared y. Cos squared y. And then vice versa for this one, I'm going to multiply both the top and the bottom by cos squared x. Cos squared x. So now in our fraction, the denominator will just be, let's use a solid line there, the denominator will just be cos squared x times cos squared y. So cos, use black here, cos squared x multiplied by cos squared y. And on top, this one is now cos squared y, so cos squared y, plus, and this is sine squared y times cos squared x. So sine squared y times cos squared x. So from here, I can't really simplify anything. I can't cross out anything in the denominator or the numerator. And what I'm going to do instead is I'm going to convert my sine squared y using a Pythagorean identity. The Pythagorean identity being that, right here in green, sine squared y plus cos squared y equals 1, which means sine squared y is equal to 1 minus cos squared y. So I'm going to make everything in the form of cos. So we're going to replace sine squared y with 1 minus cos squared y. So we're still working with the right side, so we have a right equal sign. We have cos squared y plus 1 minus cos squared y multiplied by cos squared x. All of that is divided by, we still have our cos squared x times cos squared y. Okay. Next step is I'm going to distribute the cos squared x to both terms in that bracket. So we're expanding again. We have cos squared y plus, this will become cos squared x, and then negative or minus cos squared y times cos squared x. So minus cos squared y times cos squared x. We can't really simplify those two. And technically all of this again is above cos squared x times cos squared y. Okay, so now what I have is 3 separate terms all with the same denominator. So instead of writing them all over the same denominator, I'm going to write them all as separate terms, each with this denominator. Okay, so we're going to kind of separate what we've worked to combine earlier. So now we'll have cos squared y divided by cos squared x times cos squared y. And we have our addition sign, so plus cos squared x over cos squared x times cos squared y. And then finally subtracted by cos squared y times cos squared x divided by cos squared y, or x times cos squared y. It doesn't matter the order. I know I changed the order in that denominator. Okay, and now we can do some simplifying. This cos squared y and this cos squared y can cancel out and create a 1. This cos squared x and this cos squared x can cancel out and create a 1. And this entire fraction here is actually just equal to 1. That cancels out. So now we have 1 over cos squared x plus 1 over cos squared y minus the value of 1. So let's take a look at where we're trying to go again. We're trying to equal tan squared x and secant squared y. Well, we know secant squared y is the equivalent of 1 over cos squared y. So this here we can change into secant squared y. So I'm actually going to move that to the front of the equation, okay, and write it in green. This is technically equal to secant squared y. So we have the first value taken care of. Now we got to get tan squared x. So I'm going to move this one to the right. And again, it's just addition. So we have 1 over cos squared x. Subtract the value of y. Or sorry, 1. Let's focus on this part. I'm going to make these, or I'm going to have these both have the same denominator. So same idea. I'm going to multiply the top and the bottom by cos squared x. Okay, and technically, since both the top and the bottom are 1, it's just going to be cos squared x over cos squared x. So we still have our secant squared y. We're done with that. We don't need to do anything. Here we're going to have plus. And this will say they'll both have the same denominator. Okay, so we can just write it over one denominator, cos squared x. And it's going to be 1 subtract, and this is cos squared x. Okay, and if you remember before, way up here with our Pythagorean identity, I could actually write cos squared x is equal to 1 minus sine squared x. Okay, so that's exactly what I had up there. Oh, sorry. And sine squared x is equal to 1 minus cos squared x. So go way back down. I'm going to replace the top of this with the value of sine squared x. Okay. When we do that, we'll have a secant squared y plus sine squared x over cos squared x. And that in itself is the quotient rule, which can simplify to just tan squared x. So we now have secant squared y plus tan squared x, and tan squared x was the other value way up here that we were looking for. So there is our trig identity.